looked at yesterday, trend analysis, improvement of communication and language, knowledge gathering through sessions on podcast, a LinkedIn profile, code.org to the real stuff, the coding, and then you also have the full stack, right? So this is from yesterday. So let's move on to one more area that we quickly touched upon but didn't go into detail, the technology areas that are out there, right? So we'll go into detail in these areas today. Artificial intelligence. What best than starting off with intelligence, right? And the artificial intelligence today has gained a lot of focus, lot of attention because over the last few years there has been too much enhancements in the hardware that was required to perform highly computational tasks that is required for artificial intelligence. So that is the reason why these days we see a lot more organizations adapting artificial intelligence into their day-to-day activities. So it is very important, irrespective of what technology areas you choose, you should be aware that artificial intelligence is something that you need to be knowledgeable about. To start with, you should understand what is artificial intelligence, what is machine learning, and what is deep learning. In your curriculum, you would go into and learn a few of the areas, but then when it comes to a differentiation, it should be very clear. I have had experienced candidates coming in, but not able to differentiate and appreciate what each of them are. So do understand each of them is a subset, right from deep learning to machine learning to artificial intelligence is a subset. That actually means that all of artificial intelligence is machine learning, or all of machine learning is artificial intelligence, all of deep learning is machine learning, right? So what differentiates each of them are the way they are implemented. For example, neural networks implement deep learning, and when there is the absence of neural networks, and when there is a learning that is involved without neural networks, that is the remainder of the machine learning area, right? And when there is no learning involved, there is no neural networks, then we call those areas artificial intelligence, but they still help mimic the human behavior, right? So these are three important aspects that you need to know and remember. As you go into applications, it will make it more interesting and understanding that each of these areas bring to you. So at a very high level, when it comes to learning, machine learning is categorized into three areas, right? You would have added in your academics. You have supervised learning, unsupervised learning, and reinforcement learning. There are sometimes semi-supervised learning that is being called out, but then highly at a very high level, these are the three different areas that any machine learning is categorized into, right? So what's the speciality about it? Let's start from the deep learning part, right? How a neural network identifies something. Like for instance, in this case, what you see is a car, and it is a particular variety of car. Let's say it's a Audi car, right? So if you train a neural network with thousands of images with different image augmentation, you will be able to put in a lot of computation hours into a deep learning neural network and make it knowledgeable enough to differentiate between the different types of cars. But internally, what happens is that every image, and I'm talking about there are always variants in terms of the technologies, and it's always evolving too. So I'm talking about some basic models, and maybe a convolutional neural network, for instance. So there are different layers in a neural network that actually makes it possible for the neural network to differentiate one image from another. Now, why is it important that neural networks be capable of doing this is something that we should always be appreciative of, because in the in earlier times, before machine learning, before artificial intelligence, if you need to compare two images, we manually did it, because a logic that was written in a computer language would try to uh, match pixel to pixel, which should not be capable of doing that, because there will always be differences between two cars of the same type and from where it is shot and all that. So that is the reason it is very important that these neural networks are helping us with image classification, right? So internally in a neural network, there are multiple layers, and these layers capture different types of information or different help segment the information that comes in the input that comes in into different varieties. Like in this case, right, when you take one image and input into a neural network, every pixel of it gets translated into a single dimensional array. This is a matrix. An image is a matrix, right? It is a XY coordinate, but then it becomes translated to a single dimensional, one single array, a list of all pixels, and that is what is being fed into the system, right? And these pixels are extracted and the edges are identified in the next layer. The combination of the layers are identified, or the combination of edges are identified in the following layer. So a combination of a strike and a curve might constitute the edge, the two edges might constitute the headlamp area. So similarly, all these combinations get created and features are derived out of it. That will be one of the layers, right? And a combination of these features is what helps the neural network identify that this image constitutes a Audi car or some other car, right? So it is very important that we appreciate how this is possible for the system, and only then we will be able to choose these technologies one over the other, right? An application of a software application of a technology is even more than just creating an or learning an application or learning a software, right? So that is the reason I wanted to emphasize on this slide where you should understand what has happened over the last few years that is contributing to the rise of neural networks and rise of deep learning, machine learning, etc. The GPU, the invent and the improvement in the GPU capabilities over and beyond what CPU, the central processing unit, used to contribute to, is why it becomes possible for us to use deep learning. Let us take the core, right? When a CPU is utilized, it is able to do a lot of tasks, which are bulky enough, but with GPU, a lot more smaller tasks can be done in parallel. And when I say a lot more, it is in multiples of what a CPU can do. And that is the main reason why when it comes to a neural network, it is very important that the pixel processings, which are very micro tasks, they are actually way too minimal in terms of the amount of processing that is needed at each task. You just need to go through an calculation, array multiplications, all those micro tasks, but there are too many of them. So as many parallel tasks as much as possible would make the GPU much more utilizable, much more useful than the CPU when it comes to neural networks, right? You have to understand this and appreciate this. Only then you will be able to emphasize, like I mentioned, on the application. Sometimes people ask, like, why cannot I use multiple CPUs instead of having one GPU? So there is always this capability that is built into a single chip that enhances the need for communicating between multiple processes, which is all in the same chip. The latency to communicate between one task and another becomes close to zero, which makes it most optimized rather than putting together a lot of CPUs together. Okay, so that is the reason a GPU is always a much preferred option when it comes to training machine learning models. And that actually means that your smart devices, your smartphones have at least some sort of a GPU in it. And if you are really interested, you can even start training of a small model on your GPU on your mobile phone. It will take some days to get it in any proper process. Okay, now coming to the core part, right? Now we spoke about three different areas of machine learning, and what are these applicable for? Where are these applicable? In a supervised learning, what happens? Where are these areas mostly applied? Is what we need to look at. Like in this case, you are seeing that there are two major two major areas in supervised learning. One is classification, and another is regression. Academically, you would have seen that classification is anything that allows a output into a fixed set of classes, right? There's a set of photos being sorted out into, is it either a cat or a dog? It's the simplest of the example out there. But when it comes to even more complex classifications, like for example, an identity fraud detection, or even a fraud detection, a person behaving in terms of a doubtful manner, can be the images can be classified, or the videos can be classified accordingly, right? Diagnosis of an X-ray, whether it is cancerous, whether it has anything, like a tumor in a set of X-ray, all the diagnosis can be done using classification models. But when it comes to regression, a regression is where you do not classify into a particular set, but need to know a little bit more in exact on what the output would be. Like for instance, weather forecasting. You do not classify generally a day. Like we human beings might want to classify a day as sunny, wintry, or cold, right? But we need to, at the end of the day, be able to predict if there is going to be how many millimeters of rain, or how many degrees Celsius it is going to be. So that is the reason regression comes into place, where it helps you to plot the line where this data is going to take you. So the areas supervised learning emphasizes on are these, right? Because some of you might be many of you might be using phones. I will zoom in a little bit so that you are able to clearly see the areas, right? So when it comes to supervised learning, remember that the supervised learning is a little bit more of an overhead in terms of you need to tag information to train those models. You need to give information to the model, so that to the machine learning model, so that it knows what is good, what is wrong, or into which class what type of images go, what type of data goes in. So that is the difference between a supervised learning and an supervised learning. In an unsupervised learning, what generally happens is, there are a lot more, differences in terms of how that happens. But generally, the information there is, more like the word suggests, right? That it's not informed. That the system is not, the data is not tagged. That goes into these models. So, an example is like customer segmentation. When it comes to clustering, it is very helpful that the data that goes in is, feature extracted internally by the model, and it is able to segment them into different areas. Imagine a million users on a system like, let's say, Flipkart, right? The architect there wants to know, how to segment these users. You can probably think of a few, like you can segment them using age, you can segment them using locality, their, their type, or their sex. All that can be some major segmentation that you can do. But beyond that, there would be groups like where some people might be liking fashion. They might like to search for clothes, or accessories. Some people might be electronic buyers, right? So that's something, again, at a very high level. But if you allow a unsupervised learning model to take the data and segment, probably it would come up with new segments where it would say that in an age group between 25 to 30, the electronics is split again into three different forms or four different forms. Could be a cluster that is identified by the system itself, identified by the unsupervised learning. So it is very important that unsupervised learning systems be optimally utilized according to those application. So there is no hard and fast rule on how you should or where you should apply it, but logically speaking, some makes more sense than the other. So it is up to you to understand what technology and how to use where you will be able to take a right decision. Quickly into reinforcement learning, it is more of a growing area still, where it would be possible for the training system to provide with some um, credit for an action of the system. Like for instance, a robot navigation. Imagine I'm going to write an algorithm that is going to enable a house cleaning robot. You would have seen those small black color robots roaming around in houses in these days. It's becoming a trend, and it has been introduced, I believe, in the Indian market as well. So those robots actually follow some algorithms, right? So if I'm going to do it with a reinforcement learning system, I would rather allow it to be credited with a positive feedback for some of those right movements it takes, and give some negative feedbacks for some of those that it shouldn't be. So that way, eventually, what would happen is the learning model, the system itself, would be enriched in those particular tracks that it needs to always follow. That way, it becomes more prominent, right? Yeah. So that's much about machine learning. And if you are curious about machine learning, which you should be, there are a lot more articles out there on podcasts. There are a lot more learning information. Uh, deeplearning.ai is one site you can go. There are courses for free on Coursera. Machine learning by Andrew Ng is one course out there. You can just audit it for free if you do not want a certification. But if you do still want, it is not that costly as well. You will be able to learn a lot deeper into machine learning. But always remember, as application students, right? And this is a BCA class that mostly has joined in this session, right? So from a BCA perspective, it is not that is required that you know to or you are required to create algorithms, because they may be a little bit boring and a little bit more researchy in terms of how it takes you, how it gets to implement. But from the majority, there are research algorithms that are systems that are already created, that are there are neural networks already built and available. Pre-trained models are available. You don't even start from the scratch. A Coco model, for instance, comes with millions of images already identifiable, right? So from that aspect, what you as a bachelor of computer application should be aware is that how to use this particular set of models where is should be your emphasis. You should not be trying. You should ideally be knowing how an algorithm works, how how to create a model from scratch. All that is something that is surely appreciable, but then the focus should not be solved. Like for instance, if you are a nurse and you should know to administer a medicine, it's not that you should not know more about the medicine. You should know what the medicine is capable of, the side effects, etc. But when it comes to being there out and being a nurse, if you do not know how to apply it, rather you know very good about how to create it, that's not going to be of much value, as you in your role as a nurse. Very similarly, as an application specialist, you need to understand and emphasize on what model is to be used where and how it would be effective. So from that angle, I would recommend that when you look at applications of AI, you utilize them properly, right? One interesting industrial use case of this deep learning model that I was just talking about would be an automation in a car industry, an automobile industry, where imagine number plate or a speed limit board is being identified by the car. The car needs to look out for these boards as it drives through. Human beings do, so that should happen at the car as well. So it can go into the images out there, the video that is being captured by the camera of the autonomous car, gets transferred. It should be able to take that image and identify what is the output. Is it a sign? Is it a warning? And what is the output actually meaning? Is the speed limit? And accordingly, then go back and apply the speed limitation on the vehicle's movement, right? So this is a common use case, but these are fancy use cases. Generally, not all of us get to develop, models of this sort, or are not required most of the time because there is somebody out there already built it, right? So what you have to, again, like I mentioned yesterday, look at a larger subset of the use cases that are useful for a enterprise IT. So that being said, the most common use case that happens with an enterprise IT is chatbot implementation. Again, application, right? So if I am to look for a BCA student who comes out there for a job and they have the experience of using, let's say, language understanding, Lewis system out there on Microsoft Bot framework, if they are able to utilize Bot framework and Lewis and able to create a chatbot, which literally takes about 1 hour to learn. If you're going to go there and search, knowing the basics of programming, you will be able to create a chatbot within an hour, from scratch, right? So that is something that would be much appreciative, that you will come out with an expertise, right? So it is very important that these are available. Most of the organizations When I say most, maybe not the biggest of the organization, but the next large set of organizations out there in the world are now adapting to AI in these recent years. They are appreciating the uses of AI. They understand that AI becomes affordable. So artificial intelligence's base footstep is chatbot. So you rather know how and when a chatbot can be implemented for a particular business. Like for instance, the same example like I mentioned yesterday, Zomato or Swiggy, you can chat with a person out there, but then you can always make it fully available that you put in a chatbot which can take all the basic queries, and only where it is not possible for it to answer can allow the user to go beyond that, right? We talk about chatbots, and we should understand that these chatbots are very advanced these days. It is able to, of course, process natural language. Earlier, the chatbots used to be fixed to more of an interactive voice response system, but now the capabilities have improved, where you can type in a basic question like, "When is my order going to reach me?" And it will be able to understand that the intent of that communication is the status of the order, and it can give you an ETA based on that, right? So it's pretty straightforward. I would really appreciate if you take the time that you have done today to this meeting to go learn a chatbot that is totally worth being here, right? Next, some of the other areas, cybersecurity is one huge area where implementation of artificial intelligence is being made. Because, let me give you a quick example, right? When it comes to cybersecurity, let us put a simpler example, a firewall, right? What happens with an enterprise cybersecurity specialist is that they need to keep scanning inputs of various various websites that they host. When I used to work for one of the major serial organizations, the conflicts company, some few years back, as their architect, I remember their cybersecurity specialist telling me that they keep scanning and looking at a lot of IPs that come in. They look up and see where these IPs have come from. Like for instance, a US-based website, if it is getting a lot of traction from let's say or North Korean or a Chinese IP or set of IPs, that could be that it is under a DDoS attack, a distributed denial of service attack or DOS attack, to start with. So that actually means that it's possible that that system is under attack, but a person sitting and monitoring this and identifying the pattern is virtually impossible. So these systems that are able to look up at patterns of data that come in, and identifying this threat and calling out to human or automatically taking some steps is something that would be a great use case, and that is happening these days. A lot of systems do that. Even in the application side, I remember using something called Splunk. Splunk API is a log monitoring system where the AI capabilities are allowing it to identify the patterns of an error message. So if your application is logging an error message repeatedly, it is able to group them together irrespective of the variance. Could be a regex implementation, like I mentioned. It doesn't have to be machine learning or deep learning, but it is still an intelligence that has been put in that a human used to do earlier, right? So that is a very important use case that is very prevalent in the enterprise application side. Now, one more use case that I can think of, and something that we recently are working with are, use cases in the sports industry where a lot is happening. It's not just about basic ticketing systems. Like we take data from ticketing systems, identify the patterns, project what could be the outcome of a next event. Like for example, IPL is happening. Imagine, and if you are able to exactly predict what would be the requirements of tickets in a particular stadium, or what is going to be the viewership, you'll be able to sell, you'll be able to do marketing for the event much more effectively. So it is much important that prediction of the systems are also being done effectively. That's one part of it, right? Imagine the other part of it, because image analytics and video analytics are becoming much prevalent. There are cases where we are able to identify and analyze the game of a person. Earlier, hours of video watching and analysis used to be done by human beings to tell the players or give the coaches idea of how to make a game better. Now, if there are systems that are being built, of course, not at a very advanced state, but still, are able to capably manage and tell you, the opponent generally uses the opponent team generally uses strategy 1, 2, and 7, all the time. And on rare occasions or during a penalty kick, there is a chance that a player is able to, adapt to, a particular type of a kick, right? That is going to drastically improve the chances of winning for a team. So, across industries, artificial intelligence is getting way much powerful. So, when you come out as a graduate, it is important that you have some idea of how to implement. And believe me, it is not as complex as it would sound because there are a lot of models and a lot of algorithms out there that are pre-built and available. It's a matter of sitting on Googling the right terms, identifying the trends, like I mentioned yesterday, and picking the right tools and running it out and testing it for yourself. Okay. A quick look into some of the technology stacks. The PPT here contains the links to most of these images that I'm sharing. You can always look up or you can search for technology landscape of any of the technologies out there. You'll be able to identify, you'll be able to see what are the technologies that we are talking about. In this case, what we see here is some of those companies and startups that are emphasizing on the natural language part of it. Spacey, for instance, is a very common component that we use in natural language processing. For development, use other areas like this, like Bonsai. For data capture, we can use Cloudflare, Cloud AI, all that. And from an open source perspective, like there are lots, CNTK, Keras, H2, H2.A is something that you have to watch out for. It's a system that allows build models almost with zero data science capability. Right, so these are areas that are actually trending up. There are hardwares. NVIDIA is something they would have commonly heard of if you have a good gaming system in your house. If you have a laptop with a GPU, NVIDIA is probably one that you might have chosen. But there are other players out there too that bring in such capability. Then, similarly, there are other leaders in each of the spaces, in each of these areas that you can look for and learn. So go out there. Kaggle is one good area for data science where you can go understand what are the challenges that are out there. They provide you with challenges where you can go learn for yourself and try and compete with others. So I'd highly recommend that you utilize these opportunities as you learn to get yourself prepared for the industry. Some of the AI technology stack in itself, apart from some of those what we saw there, common ones. Like I had mentioned earlier, Spacey, TensorFlow models are pretty straightforward to build. You can use Keras and Pandas. These components are pretty much a few lines of code, to start with. And if you use them effectively, you'll be able to achieve a lot more capability as you implement them. For instance, OpenCV. A few months back, when we used to work at office, set up a small OpenCV algorithm that would OpenCV set of APIs commands that we put together into Python code and was able to automate the facial recognition of the people who enter the office through the CCTV footages. So it is pretty straightforward, and it took maybe like an hour and a half to understand the Python code was required and then implement this. So it is as easy as that. Okay. Okay, let me quickly take a pause and check if I'm still audible, I'm still online.
Oh, yes, sir. You're audible and everything is going on well, sir.
Perfect. I hope we'll go into more complicated screens. I know most of you are on mobile phones, so it wouldn't make sense to go in deep into this. But like I mentioned, I would share this and I have this available PPT. And this is not just that you need to come and see in this PPT. You can search for technology landscape for any technology area, and you would get a wide system, or literally a full set of collection of all the technologies, all of companies that are providing capabilities that you can go and look at. For instance, when it comes to, let's say, visualization, what's available in visualization? You can see here, right? SAP HANA, Google Cloud has visualization capability. Tableau and Power BI are the leaders, undoubtedly, right? And these are available out there. You just need to go do a little bit. You will be able to, understand what they are capable of, and that is good enough. Once you are presented with an opportunity, you can always learn the details. But if you know and appreciate what each of these are capable of, you are opening yourself to a wider, chance of getting into an opportunity, into a job, and also implementing wonderful, applications. So I'm not going to go deep here. I do not want to frighten you with these images, but please do go research on them. Let us quickly look at the big data, capabilities in terms of when we talk about AI. We should also understand that it is possible that AI is successful today mainly because of the amount of data that is available, and the data capture and big data has been a major player in making it possible. Being able to store massively scalable systems. I wanted to quickly highlight on one particular big data component, Cassandra. Cassandra is one of my favorite databases out there on the NoSQL side. So like SQL, like structured query language, NoSQL is that other language that or other technology that is gained a lot of momentum. Mainly because if you take a step back and see how RDBMS is implemented, you would notice that RDBMS has a rigid system. There is a CAP theorem, CAP theorem. Remember taking notes. I would highly appreciate you do that. The CAP theorem emphasizes on a few areas like availability, partition tolerance, right? Consistency. All these are important aspects of any database system. But when it comes to big data, we bring in a flexibility in these capabilities. Cassandra, for instance, is famous because it was the database that the Facebook team implemented in their Facebook system. So if you have used Facebook, you have used Cassandra. So what happens there is that imagine using an RDBMS for the scale of data that Facebook is bringing in. Messages that come in, the clicks of likes, shares, everything that is happening in Facebook. Imagine the millions of records that flow into Facebook at every moment. Putting that into an RDBMS is virtually going to be impossible. Technically, it is, but that would mean that it's huge systems that needs to be implemented. So that is where systems like Cassandra play a great role. In Cassandra, for instance, if you look at this simple architecture out here, there are hundreds of nodes, and rather there are actually 10 nodes that you see here, and these 10 nodes are distributed and also make sure that the data is distributed across them. Like you can always set up that you need to have 3 copies of your data, and now there's high chance that one copy resides in the node 1, another one resides in no. So in this case, right, there are 3 copies. One copy resides in node 20, another copy resides in node 40, and another would reside in the node 100 itself, right? So that makes that in case this node goes down, those other nodes can pick up and run version. One of them will take ownership of being the primary node, and they will make sure that the cluster is intact. There is a lot more to this, and it is not a part of a session that we can talk about Cassandra. But why I wanted to emphasize this here is that in your journey in the software industry, the most important part is software, right? In IT industry, unless until you go into the hardware industry and look up something there, you still mostly would be having a chance of working for a software. So let me focus on the bigger the group here, and hoping that you go into the software industry. You should learn from the architectures that are out there. In this case, the Cassandra architecture is one wonderful architecture which enables data to be partitioned across more effectively. Thus, it creates the basic commodity hardware as a database system. So I can have 10 different computers, in a network or in 2 networks, and make sure that the database becomes even more effective than an RDBMS. And eventual consistency is something that you can build into and distribute the data across. Like, for instance, as I had mentioned on Facebook, if somebody likes your photo, if it takes about a second or two for you to get the update, it is okay. But it may not be the case when it comes to, let's say, a bank transaction. You withdraw your money from your bank, the consistency is the highest factor. So under the CAP theorem, under the CAP theorem, consistency will be the highest. But when you emphasize on consistency and maybe partition tolerance, your availability goes for a toss. So you would not be able to distribute or increase the load. So that is the reason banking systems would be running in very highly sophisticated database RDBMS hardware, right? They would be having RAID systems, RAID capabilities, PHY or I, right? So that is the reason. These choosing the right technology for the right application is important. Somewhere where you don't need such an high consistency, you can always tune the consistency for eventual consistency. That doesn't mean that it's not going to be consistency, but it might take some time for the consistency to come in place. The data that lands in the first node might take some time to go to the other nodes, but it is not going to be a killer. Generally, if you see this, a write request comes in, it goes into a mem table, then it goes to an SS table, and then parallelly it also goes to the commit log. The SS table and the mem table and the commit log are three different mechanisms that Cassandra uses to bring in consistency. So during this time, the equivalent of a dirty read in RDBMS might be something that you can compare this to, right? So that would mean that the read request makes it very fast. So you can tune the system to enable faster writes and maybe slower reads, or faster reads and slower writes, depending upon various configuration that's available. So that is the reason why I called out explicitly that it is very important appreciate the architectures of such systems. You can learn a lot from there. You can implement them in your own projects and in your own design patterns. Okay, going on, I want to quickly, in case you do not are not aware already about graph database, I wanted to call out that this graph database is something that is catching up and becoming more powerful. This is also a form of a NoSQL, not a structured query language, but the capabilities of GraphDB is bringing in is much high. Now, imagine this data that you see here. It is a graph. A graph is anything that has nodes and edges, right? There are edges connecting each nodes. So as far as there are nodes and edges, you can build data. That is the same case as in a RDBMS. You have tables and your relations. The pretty same concept. So what makes GraphDB more perfect is that the architecture, of course. And I'm not going to go deep into the architecture, but let us quickly look at an example of a Cypher query. Cypher is one such GraphDB query language. If you look at Neo4j, Neo4j, it's a graph database implementation, a pretty famous one. So there you'll be seeing the Cypher implementation, and this is an open Cypher implementation for other RDBMS or other graph databases out there. But the Cypher in Cypher languages, in language, in order to see these two nodes are connected as is married to relationship and is married to Dan, right? To find out person and's husband's name or spouse name, you can write a query like this. It might look a little bit of a Greek and Latin to begin with, but it is pretty much a colon, curly brace, and a few codes out there apart from the actual English itself. So it is asking to match a person with name Anne with the relationship of married to and call it as a variable spouse. So it's as simple as that. So this capability actually makes query graph query language for GraphDB is very powerful, and with the speed and performance that they can make this available, it is very effective to do analytics on top of it. So we implement in our systems GraphDB for some of our implementation from analytics, and very effective. So I would highly appreciate if you would go back and look up a graph database and understand it. Some of my colleagues were able to get Neo4j certified in a matter of a couple of days. As as effective as it is. So I would recommend that to you as well, right? Go find out what is a GraphDB. You know RDBMS, you know DBMS. So GraphDB is going to only add to that capability. And these are evergreen fields. Once these databases really get a hit, get successful, then they are going to be around for a long time. What I learned in my college days, I still applies in terms of RDBMS. So NoSQLs are there to stay. So please do emphasize on these areas. Again, another fancy slide with all the GraphDB related systems. So as you see here, Neo4j is out there on the top. There are other graph databases available, but they are still the leader. You can at least find out how it is implementing the graph structures. And you can, like I mentioned, a day or two, and you will be able to come out as a certified GraphDB specialist, right? There are other capabilities, there are other systems that are related to this, like for example, ClickView, Tableau, Power BI. They are all beginning to open up for GraphDB to be able to connect to graph databases and create visualizations from them. So it is pretty interesting. Do focus on those areas as well. So it will be a success for you shortly. So that with that we will pause a little bit on the AI part, go into a little bit into the business intelligence portion, business performance management, data governance. All these are areas that comprise a lot about how business process can be implemented, automated, and governed. A lot of it is related to data. So if you go into becoming a data scientist, you need to be a veteran in terms of understanding what a business intelligence system is capable of, and in terms of not just the visualization, in terms of integration, extracting information, storing in the data lake, in a data warehouse, understanding the governance that needs to go in. To give a very high level example, right? Any system, let's say a retail chain, let's say uh, Flipkart again, right? Flipkart has a lot of data flowing in. For instance, they might be gathering millions of records every day. The moment the data comes in, and they're not just coming in from one source. If you believe it or not, let's say a quick example of Google Analytics. Somebody has implemented a Google Analytics in the system. The Google Analytics data is also going to flow in along with their e-commerce information, making sense of both of them, taking the right data, using data governance to make sure the right data is converted to the right format and stored in the data lake, and then extracting information, putting them into facts and dimensions on a data warehouse is very important. And it's not just for the sake of accumulating and analyzing. There would be systems that take data from there. And most of the software oriented businesses out there sell out information, not your personal information most of the time. It's about analytics. For instance, if I were Flipkart, and if I have that capability, I'm going to surely build a system that should tell me, where, in which part of the country, for instance, in India, which state requires the maximum apparels, who is the biggest consumer, and one type of apparel is being looked up in which particular season. During summer in Rajasthan, maybe they are buying dresses made out of cotton, obviously, right? But that information being pulled out there and being made available would greatly enhance the opportunity for somebody to focus in that particular market and design that particular model of dresses that might take them to a successful sale. So that kind of information is available with them. Like our great Sindel who said, information is wealth, right? So you should always remember that business intelligence is something that takes you out there to building great systems and utilizing data to your strength. It, of course, improves your decision-making processes. It makes it easy to access and share information. There are, 2 to 3 different major ways integration happens. One is real time. where as and when a system updates something, the request comes in or the data flows into the system. There is a batch process where at the end of the day or periodically a set of data is being sent into the system. And then there is a combination of this, a near real time where it is not as fast as a real time system, but it still would be passing information in a bit of a staggered manner, right? It helps reduces the risk of the bottlenecks that could be there in terms of the benefits, right? So these are some of the high level business intelligence benefits. It's a major area. A lot of data analytics happens here. Customer behavior analysis, budgeting and forecasting, which are very important, e-commerce analytics, marketing campaigns, supply chain optimization. Unlike earlier times, there is not a major go down out there or warehouse that simply keeps piling up piling up manufactured goods. Manufacturing of goods happen on a need basis, so that the necessity to older stock or is greatly eliminated. Up to the factor that I believe in Amazon you can order some books and they are printed on the basis of your order. So that much optimization has come into the supply chain. Of course, Amazon and this use case of a book printing is not their general supply chain optimization, but it is one sort of where you do not need to keep something out there ready waiting for your customer to come in on demand, on as and when required. A print is done or a a process is built and sent out, right? Product is built and sent out. Pardon me. Right, so that is how effectively business intelligence can work, and with a combination of business intelligence and artificial intelligence, which is now very imperative. Most of the business intelligence software out there have their own AI components, enabling it to become even more smarter. So let us go into the automation area of business process management, where RPA is one major player. Robotic process automation. Robotic process automation ideally is not meant or was not meant for technology people like us. A BCA is not expected to be learning and implementing RPA, but the market today has adapted to implementation of that sort, where bigger organizations still come to IT and IT services organizations to implement robotic process automation. So, what is robotic process automation? Let's take an example of uh, again going back to, let's say, Flipkart. A lot of invoices come out there in their system, and they have a legacy system. Let's say they have to take all your GST data and process it into a particular format and submit to the government at the end of the day, and somebody had to do it manually because that integration is not there. There is no API available. So there, robotic process automation can step in. Robotic process automation can mimic the work of a human to a greater extent. Whatever you can do on a computer, you go here, you read this, you analyze that. If it is R, then you realize that it could be a robotic process automation word, and then go click in particular part, do something. All that is possibly automatable through a robotic process automation system. Again, like I mentioned about the other tools, these are pretty straightforward, very easy to learn. The basics are very easy to learn. For instance, if you go into UiPath Academy, if you Google for UiPath Academy, UiPath is one leader in RPA software. Similarly, Blue Prism, Automation Anywhere, and quite a few are there, right? But take one for example, right? Maybe can be your next weekend exercise. Go into UiPath Academy, spend an hour or two, and you will know what it is to be using an RPA software. As easy as that. And if you spend a day or two, you can get a certification that makes it capable that you become a person who can implement a small automation pretty straightforwardly using a RPA tool. As easy as that. So, obviously, because it is automation and it is involving computers, the employee morale is improved. Imagine yourself sitting out there looking at an Excel sheet and updating another, or putting it into a system. You are going to be a dullard at the end of the day if you are going to do a manual activity. But if a RPA is implemented, you can use that time to become much more effectively, performing some other more intelligent activity. So RPA generally tries and removes of the manual overhead that is there for any particular job. So now let me take a quick pause here and uh, emphasize on one particular action. There is a general trend that people immediately say, "Oh, with all this automation, jobs are going to go." There is a possibility that there will be reduction in jobs. But imagine if that was the case and nobody adapted to using the wheel, right? The round wheel that is out there, that was invented, hundreds of thousands of years back, right? Or maybe millions, I don't know. So, when 100,000 years back, when a wheel was invented, imagine somebody said, "Hey, if I use the wheel, I can carry more load, so I'm not going to use it because all the 10 people along with me would lose their job." Right? That doesn't work that way. Similarly, with AI, with RPA, with automation, there is going to be changes in the way work is done, but that doesn't make that people are going to run out of jobs. They might run out of their current jobs, but there will be more opportunities that are identified. So be open to the thought, and of course, it is our opportunity that we are on this side where we create and build a software, utilize and implement them. So it is more important that we optimally learn these technologies. Productivity goes up, reliability goes up greatly. You can ensure if you write a proper bot, they call it a bot because it's part of the robot. The bots that you build with an RPA can be very effective without any issues if you do that correctly. Consistency is there. All that complaints can be brought in place. All that can be implemented using RPA. Okay. There are some vendors, quite a few. The top three are the top three, mostly used by many, but then there are variations. They're costly. Like for instance, a UiPath license, I believe, comes around about $10,000 a month, no, or a year, which is pretty costly. But compared to US implementation of the same, a user or 10 users having to use that same capability would be costing them much more, hundred of times more than that. So that is where these RPA tools are more effective. There are open implementations. There is a Pi RPA as well implementation. I believe we were discussing this recently with one of my bosses. So there are implementation softwares available out there that can do automation very effectively. So better we adapt, and stay out rather than being automated out of the system. We discussed about Gartner, right? Isn't it important that we utilize here as well? So look at it. The leaders in Gartner's quadrant is UiPath, Blue Prism, and Automation Anywhere. There are niche players which have some particular capabilities in terms of automation, but then there are visionaries that take them to the other levels. Pegasystems is one such, and then there are challenges that are going pushing the limits and trying to get to leadership positions. This is a year old. That should be drastic changes, in terms of the niche players entry right now. Cloud. Okay, so it's very important that we talk about cloud, when it comes to all the technologies, because a cloud, in software terms, is a culmination of mostly all of this. Cloud mostly is spoken from an infrastructure perspective. Then that is the core of it. It is very important that the infrastructure be made available, highly available, and scalable. But it is even more understanding that these infrastructure companies out there, Azure and Amazon Web Services, have added much more capabilities, right? From AI and data into IoT, blockchain. All those capabilities have been built into the cloud offerings that they have. Amazon has thousands of services out there. Like I mentioned, from the basic infrastructure component to the most advanced components. Very commonly, some of them that take away the maintenance overhead from you. You do not have to, of course, the moment it is on the cloud, your hardware maintenance overhead is removed, the infrastructure part is gone. But it also takes away the platform overhead, and it also takes away the server overhead from you if you use the right component. We will go there shortly, but let me quickly check if we are still fine in terms of hearing, seeing, ma'am?
Yes, sir. We are able to hear you and we have the
Okay,
clear picture.
perfect. Thank you very much.
Okay.
Okay. Okay, so when it comes to cloud, right, there are three leaders, like you see here: Amazon Web Services, Azure, and Google Cloud. In the same order, I would say, because of the amount of services and the infrastructure they possess and distribute. But then there is a constant competition among them, particularly between the top two, right? Amazon started as a book company, and once they understood that they had a lot of surplus infrastructure available, they built a very sleek infrastructure sharing capability, which is today available through this Amazon Web Services, and they have been building, and now their book business is a smaller portion when compared to the billions that they make from the cloud services themselves. I'm a big fan of the cloud mainly because I had the opportunity to implement one of the major organizations onto the cloud and migrate their on-premise infrastructure to the cloud. So, obviously, like it makes sense. You can scale on demand. I'm not going to take a lecture on what cloud capabilities are because I saw that you have those in your curriculum, in your syllabus, right? So you will be able to learn those, but how they are implemented, how they are useful is something that we'll quickly touch upon. For instance, first you need to understand the differences between a on-premise infrastructure as a service, platform as a service, and software as a service system, right? On-premises, everything you do, all these blue areas are something that you need to do on your own. You need to have the networking, storage, servers, if you need. Of course, most of them do have virtualization set up. On top of it, they have operating systems, the middleware, runtime, data, and application, right? All this on your own in your literal office is on premise. You buy hardware, you take a server, you bring it on into your office, you put it to the software, put it into the hardware rack, and you connect them, put networking. All that is done. You install something like a VMware to make sure that a huge server can be divided into multiple operating systems or multiple servers internally, virtual machines, and then all these other things on top of it will be on premises. But when you go to infrastructure as a service, you go to any of these cloud providers. For instance, on AWS, it is called EC2. Elastic Cloud Compute is what they call it as. EC2s are their infrastructure as a service component. So where everything is taken care of, you can just connect through a remote desktop. Uh, of course, operating system is your overhead, but they also give an option of remotely getting this operating system deployed. You should have to maintain it. That is where this is still in blue. You can connect to the infrastructure that is deployed onto an EC2 remotely. You can RDP into it. You can do a remote a remote connect through all other protocols. You can do FTP. You can file transfer them. You can do SFTP. You can do all those protocol. You can connect to the operating system through various capabilities, and you can start using that. You have to build that machines on top of it. All of the things you need to build. That is where an infrastructure as a service works. And when it is possible that you have a software as a service available or a platform as a service, you might still need to use infrastructure as a service, because sometimes the operating system or that particular software that is built, it might be a legacy system that doesn't support you to you to run it as a platform as a service. So that is the reason might be sometimes you have to go for an infrastructure as a service. But if it is not a need, you can always try and utilize a platform as a service or a software as a service. Software as a service, and a simple example is your Gmail, right? Your Outlook or your Office 365. Those are examples of software as a service, where the software is available. You just log in and use the features that are available. You check the mail directly. You don't need to worry what operating system it is running on, whether it is integrated with another data source. Is it running on Java or .NET? You do not have to worry. You directly use the software. That is the easiest. Of course, there is a cost associated to it, but then with the scale, available out there, these costs are also going drastically down. The competition between these providers enable us to get a good deal most of the time, rather than having a infrastructure as a service, a uh, system admin managing all this. Then when it comes to platform as a service, this in between, more like the operating system and most of the runtime is taken care of. This is a serverless, or we call it a no, serverless compute capability. There are systems like Lambda or Azure functions on Azure which provide this. That actually means that what you just need to do is to write your piece of code and run it on them. Of course, you need to bring your own data and the configuration required, and it is going to enable the application to be up and running in no time, right? So in terms of cloud offering, these are the three offerings: the infrastructure as a service, the platform as a service, and software as a service. So these, you choose wisely among them. You choose to adapt from on-premise to any of them, and your systems can be made up and running in a very minimal timeline. Again, going to Gartner, of course, like we discussed, these are the leaders, and there are a few. Alibaba Cloud was catching up just before the COVID situation. I'm not sure if it's still competing out there, but they are fully, capable in terms of cost optimization that they provide. Oracle and IBM too have their own cloud, but they are much way below their current capabilities. But there are some niche areas like Watson from IBM, I believe, is providing some competition to the other natural language and AI components that's provided by the other leaders. Let's go a little bit in deep into Amazon Web Services and see what are the services that are available. Like I mentioned, most of this might be very specific to the cloud provider. In this case, uh, uh, some of them might not be available on other providers, but most of them are catching up in terms of providing those services that each of them provide. Here it is divided into foundation services. Let me zoom in. So like I mentioned, the EC2 and Lambda are compute foundations where you can put your code. Of course, on EC2 you need to manage the operating system and all the required middleware and platforms that is required to run the source code. But on Lambda, you can launch a Python Lambda or a Java Lambda, which has all those capability, and you just need to put the code there. So it is going to just provide that compute capability. You need not worry about what is the operating system. You need not worry about patching it or running a virus scanner on top of the operating system out there. So that is the capability that this foundation services of compute provides. Of course, in terms of storage, CloudFront, Glacier, S3, and Elastic Beanstalk, these provide a lot of storage and content delivery. We'll keep content delivery out there, but in terms of S3, data storage is possible and it is available at scale at a very minimal cost. If you are not utilized it, and if you are a big buff of storing a lot of data on your laptops, you should consider creating a free account and storing a lot of data onto the S3. That way you can have a backup of it and to be downloaded at a later time, right? Uh, Content delivery network is a major area to it. I'm not going to go in there, but databases, right? We discussed RDBMS databases, data warehouses capabilities, and in-cache memory, in-memory caches are also available. Elastic cache is available. So these are the different databases available. These also provide, compute, but from a database perspective. The different networking capabilities. Route 53 acts as a DNS gateway. The virtual private cloud, direct connect, that capability that allows bigger organizations to have a direct network from their office to their cloud provider, right? When it comes to application services, the PaaS services that we spoke about, there are quite a few in terms of administration. Like for instance, IAM, Identity Access Management, is a huge area. In order to identify a user uniquely is very important, isn't it? So from that perspective, IAM actually gets plugged into almost every other service where AWS is concerned. There is, CloudWatch, a monitoring service that enables to look up and see what's happening, find out security vulnerabilities, configuration issues. All that will be possible through CloudWatch. We spoke about DevOps briefly yesterday. DevOps is possible through the DevOps capability that is available through deployment and management services. A lot of operational activities can be automated. You can connect to a code repository. You can take the data from there as and when take the code from there as and when it changes and deploy it onto an environment and track all this, right? So quite a few features are available, and this is just a tip of that huge list of services. AI services are available, so there is a wide variety that is utilizable. You can just sit out there and in a matter of minutes uh, make this. Like I mentioned about OpenCV, right? Instead of using OpenCV, I could have always gone to AWS recognition. That is an AI service available that is not in this list. It can be trained to quickly identify people's faces, and they can not just face anything, but yeah, it can be easily used to do this on the cloud. And because it is available at scale, I can do thousands of images at the same time, as much as I would have with a laptop in hours. Okay, so that's something that you need to be watching out for if you come out of an organization of a college, and if you do not know cloud capabilities and their real-time implementation, it's going to be a great waste of your 3 years or 2 years of education out there. So please focus on try to learn cloud capabilities. Pick up one, pick up Amazon or pick up AWS. GCP is a little out there, not at to the level that these others two are. So when you put something on your resume, even as a fresher, it would really stand out if you put a cloud capability. But by the time you come out, I'm pretty sure that would be the case for most of them. And again, let me call out the syllabus would cover the basics, but you should have a real-time experience. So go out there, create a free account on Amazon or Azure, find out what it takes to actually deploy a piece of code, run it, and perform one particular action. Okay. Uh, Almost last, but very importantly, like I had spoken about the architectures. This is a simple architecture I put a few years back. I think 3 to 4 years back, but still most of the components are much relevant. This is an AWS specific architecture because of the components that are being used here, but with minimal tweaks, we can create one similar for Azure or any other cloud provider. And it is not just about cloud; it's about an implementation. So let me quickly, in the matter of next 5 minutes, walk you through what is happening here. There, it might look like it is a lot, but it's about being able to deploy and deliver something. Right? What happens here is there is a Route 53 gateway through which requests from mobile users, for instance, comes into the system. It goes through the cloud friend. It goes through an API gateway, gets to a elastic load balancer, which load balances is the request. Load balancer is basically about having the capability to distribute load between multiple systems. Only one system can only handle so much, right? So you should be able to add more such systems and scale. The auto scaling group capability in AWS ensures that the as and when the load goes up, like for instance during Diwali time, my Flipkart application is going to be loading, or my Amazon app is going to be bringing in a lot more users. And it used to be the case. I am not sure during these times what is going to happen, but yes, still, people are in a mood to buy something. They're going to be buying in lots, and that is going to convert into the number of requests that would come into the systems. At least they would be browsing, right? So at that time, ideally, we should want to scale up this infrastructure. The compute capabilities have to be scaled up. But the advantage of these cloud systems are that they do not charge you by the month; they charge you by the hour. So every hour, like from 1 to 2, you have used an instance. At the end of 2 o'clock, if you're stopping it, you are not going to incur the cost for it in the next hour. So it is very important that you scale up and down as and when needed. So the auto scaling group can be set with rules that would enable this to scale up and down based on the amount of input that comes in, right? And then there are gateways, and there will be a RDBMS solution. There could be a data store that really doesn't have to be through RDBMS, like we discussed earlier, because of the huge amount of data that is going to come in. We would rather have a NoSQL implementation, a small cluster here and there that could distribute the information between these, and then also provide a separate uh, data warehouse capability for analytics to be able to perform some actions. Like for example, a data science or a development team member can come in, look into QuickSight, the Tableau equivalent, the visualization component that can go into Redshift, do look up the dimensions and facts out there, and find out what's happening with the data and make predictions and actions accordingly, right? So at a very high level, this is what the data talks about. There is a little bit more in terms of a VPC, the virtual private network, that each account comes in. You can create more than one in an account, but that is what it is. And then there are availability zones within a cloud where one uh, data center of Amazon, for instance, or of AWS, has multiple regions. Like within the US, there are like 6, 7 regions. One in the north, two in the north, one in the west, one in the east, all that area. So you can distribute the data to be stored across, and even the compute can be stored closer to where the data comes from, where the requests come from, so that it will be much faster. Latency will be highly reduced, right? So it is important that you design an architecture, and it's more important that you start learning how to read an architecture. Okay, so that is pretty much what I wanted to cover today. I believe something is missing. Yeah, that is what are the key takeaways from today's discussion. What we discussed: AI, ML, deep learning, GraphDB, RPA, robotic process automation, DevOps, serverless compute, IaaS, PaaS, SaaS, and basically about emphasizing on architectures. I believe that's all what I had to share today. I'm not covering everything on the technology, as I clearly mentioned. This is just a subset of what's out there, but these are most prominent and something that can be covered in this matter of time. Let me take a pause and see if you have any questions. Yes, ma'am.
Good evening, sir. It was a real wonderful session, sir.
Thank you.
And then the first question, one Mr. Mayub Ghosh,
Okay,
why not use multiple CPUs instead of GPUs, sir? Because
very
he
good.
says, yeah, there's a question in the chat box if you see, sir. And he
Sure.
says these GPUs are better in rendering high resolution images and videos, but whereas its workspace is very slow. So why not use multiple CPUs when compared to GPUs? That's what his question is, sir.
Okay, it's a good question, and I believe I answered that during when I was saying. But let me bring it up again. So, like I mentioned, right? So imagine you put together multiple CPUs, and what happens is when you connect these CPUs between each other, there is a lot of latency in terms of the amount of time it would take for data to flow between these CPUs, right? Not only that, there is going to be a need to have the abstraction of application. You have to write application specific to what is required for communicating between the CPUs. That is going to drastically reduce the amount of output that can happen from multiple CPUs. In the same time, with GPUs, and along with it, the capabilities that some latest programming languages bring in, like for instance, Python. All right, you can do matrix multiplication with one single line, and if you write the right code line, it would use GPU instead of a CPU. So that would make sure that the micro activities that needs to be done. Again, I'm not talking about normal tasks. Normal tasks generally go to the CPU, which would be more optimistic. The accumulators and the processing capability that CPU contains are quite different from the GPU. Why GPU is used for enhanced UI on a mobile phone or on your laptops is because there are activities that happen at a pixel level, and there is a lot of pixels out there, right? The HD capabilities show you that there is 1024 into 768 combination that has to come out on a screen. So if you do that through a CPU, it is going to be slow, and that is the reason in GPU is much faster. The same reason the neural networks need those amount of processing. Like I had mentioned here, now if you see this, the image here is like a mobile screen or any screen. It's graphical. So in this case, the image would have actually been transformed into a single dimension array, and there are a lot of small bits of processing that happens between. The comparison happens. Is there a line or not? Is it for from this particular pixel, for instance, right? It needs to find out if it is actually a material or not. So that is an amount of processing that is required. So that is the reason I mentioned that GPU enhances and makes it possible that neural networks be trained. Even without a GPU, a model can run. But for training, we highly recommend having a GPU. Without a GPU, it's going to take months together to train some of those models. That happens in the matter of hours when it comes to GPU. Yeah.
And the next question, sir, he says that he uses MongoDB instead of Cassandra. And then MongoDB stores data using documents. So he says, is Cassandra better in any way?
See, you cannot compare apples to oranges, right? There are different purposes. Like I mentioned, an RDBMS has to be used where there is application-specific data, for instance, is still the right option, right choice. MongoDB, like you mentioned, is a document store. There is a JSON structure that comes in. I'm not going to utilize Cassandra. So, like I had mentioned, Cassandra's use case was for there are multiple use cases, of course, but when there is data like Facebook feeds that come in, which is not huge. The size of each of the feed, like for example, implementing a Twitter, for instance, right, is something that might be optimally done in Cassandra than in MongoDB. But these are systems that can actually be optimized in terms of their capacity. That cap theorem I spoke about, I can optimally tune which one I need to increase. I should increase the consistency. I can do that. I can say that the response to a request, a write request, goes back only after it is exactly identifying or it's actually writing it in all those three separate nodes. So that actually would slow down the system, but it would still be more like an RDBMS if I tune the consistency to increase. If I delay the consistency, I can make partition tolerance and availability even more prominent. So there are different use cases. Again, there is no one solution to most of these use cases. I might use a combination of Cassandra and MongoDB. Okay, I think you got it.
Okay, sir. Thank you, sir. The next question is one Mr. Jahir Hussain. He has asked,
sure.
Is Sybase and Informix still used in the industry?
Should be, right? Because what happens with these systems, right? These are like I'm pretty sure. Again, I'm not a judge, and of course I do not use it, or neither any of my direct projects that I had been involved in the recent times. But I remember seeing Sybase in use even a few years back in one of the organizations. So they are surely available. They are huge systems, and if COBOL and mainframes are being still used, systems like Sybase should be out there, and Informix also is out there. But if you are going to prepare yourself in the later technologies, that would be highly advisable. Like it is like being coming out with a older style dressing pattern. It's not that you are not going to be fulfilling the need for clothing, but you would not be readily accepted into the community because you are not into the major fit. You can still develop software using those technologies.
And the next question, sir, he has asked that infrastructure as service, same person, Mr. Mayuk Ghosh, infrastructure as service, platform as service, and software as service as a combination, if we use, it would be better, or simply if you use software as service, it will be better? That's what he has asked.
Yeah, I believe I touched upon that as well, right? So
Yeah,
like
yeah.
I showed you on the, let me quickly show that slide again, so that it's an important question. It's a good question, no problem. It's always the case by case basis that you need to use that. Like for instance, in this architecture diagram that you see here, right? Some of them could be here. It is mostly PaaS, but sometimes you may want to use uh, a software as a service. Like if I'm going to use mail, I'm not going to write a SMTP component out there and put it onto a PaaS. I will still directly use the mailing component. So a Gmail or a simple mailing service, SMS, I believe, is what AWS's services for mail. So that will be a SaaS service. I would directly use a SaaS service along with the PaaS services. And like I mentioned, sometimes some software may not run on any of these PaaS systems. So I might have to have a infrastructure as a service, an EC2 in this case, to be deployed, and I might have to run it on that EC2. So a combination is what would be required. But when it comes to building an enterprise, right? Imagine I am the global head of a major retail chain, like for example, like P&G or sort. No, I would rather not invest time and money into building people. That is the current trend. It's not that it is right or wrong, but I would rather allow somebody who has built some software out there, and integrate it with my system rather than going and build something competitive to somebody. I would rather integrate them together and build an ecosystem for my enterprise. So SaaS will be the first option. Again, not for everybody. It depends on who's the user, and so it is a on a need basis that you might take one or other.
Actually, sir, most of us who attended this seminar, we are all from the educational background, and we are
Okay.
not from industry background. So, got some basic questions as well.
Sure.
For example, Keras, TensorFlow, Scikit, and all these we have used for ML, sir. But could it be used for DL as well? We are not
Uh,
sure.
TensorFlow as a yeah. See again. Of course, I'm not going to compete against any of your academic knowledge, right? Just do a basic Google and find out. I am not a expert. I'm I am a user. Most of the time, there is limited amount of expertise that I have. Like for example, TensorFlow, right, as a model that I believe a deep learning model that I have implemented, or my team has implemented, in terms of creating a image recognition classification model. So it depends on a case-to-case basis. Some of them have capabilities to implement deep learning. Some of them do not. Some are neural network specific. Some are like we saw earlier, learning capabilities.
Thank you, sir. And then Cassandra cluster, the NoSQL SQL
NoSQL, yeah,
database.
yeah. Mhm.
That one, is it open source, sir? Open source.
Yes, Cassandra is open source. There are organizations that they have adapted. Like for example, I believe DataStax is one company that has a Cassandra, flavor to it. So they license it. You can still use theirs, but when it comes to support, I believe they charge something. So otherwise, Cassandra is open source. Facebook built it, I believe, and they have open sourced it, so it is available out there. Yes, it's a very interesting platform. You should take a look at it.
Okay, sir. Does Cassandra use GraphDB, sir?
Uh, Initially, no, but Cassandra has a capability of graph, I believe, in the recent times. Initially, it is not it is a NoSQL structure without graph earlier. Like I showed you the architecture, what I showed is what it is.
Yes, sir.
But it doesn't use graph in the basic implementation. It uses a variety of file system based stores to make it possible for you to create this tunable consistency.
Thank you, sir. And any other database that uses GraphDB? Could you name anything, sir? Sorry,
Names,
I'm
okay.
asking you a lot of
No, no, that
questions because
no,
we
you
are
should, you
curious.
should. No, no, it's very,
We are
very,
not
very
into
important.
the industry, and we are curious to know whatever you input you can give us, sir.
No, no issues. like I mentioned, right? My knowledge is also limited, but Neo4j, like I had shown in the slide, and I will share this slide with Mrs. Roshna Rabano. I did it from yesterday's. You can surely reach out in your group and get the slides. And from each slide, I have added notes. Most of them are not my own diagrams. I think this is one I drew many years back, but most of them in the slides. Okay, let me share my screen and talk. So in the slide deck that I have put together, I have also captured where this data is taken from. So if you look at in the notes section, the URL to that would be available. So you can go through them. You can go to the source. To answer your question directly, the Neo4j is one graph database that is out there. So in Neo4j, it is a very small. Let me try and zoom it here. You see it here, right? So there
Yes,
are
sir.
Janus graph. There are multiple DBMSs that support that are graph DB, that are like natively graph DB. But
Okay,
then
sir.
what happens these days is because they have to adapt. Most of the bigger players are also bringing in graph into their system, like like SQL Server and all that. But yeah, if you need to learn one, I would say Neo4j is pretty cool because, like I showed you, right? In this, it is pretty straightforward to implement a graph query by using Cypher. Cypher is the name of the query language that's used here. So it's pretty cool, pretty easy. Again, one quick piece of advice I would say, if you try and learn technologies, of course you will be academically successful, right? And which you should do. Everybody should have to complete their syllabus, their courses. But I recommend that, and I do this to everybody. I ask them to pick up a challenge. Try to replicate something if you don't have an original idea. But if you have an original idea, maybe implement an application. Try to come up with the idea of an app, and it's not just an app, right? You just don't need to do a mobile application coding. If you have to, you can always or you have to go back. You have to put in the infrastructure that is required. You have to put in the artificial intelligence that is needed to process the amount of data that could be coming from these apps, right? So try and take up one such challenge and implement it, not just for your college project. If you do that, it will be great in terms of the amount of uh, knowledge you would gather in that process. Right? Don't do the project for the sake of it. The academia has a very good structure. The projects are required so that you explore the technology that you learned. But we try and complete it off in the easiest method. I would rather recommend you don't go that route. Take it up as a serious activity. Start it earlier than in the last final semester, and try to implement all that you learn in this. Implement cloud, implement AI, implement data mainly. In some form or another.
Thank you, sir. And the last question, sir. The AWS Lambda that you said, sir, used for computation, is it similar to something like Google Colab, which is used for implementing ML algorithms? Just a confirmation, sir.
I do not know Google Colab, so I cannot comment on that. A Lambda is more closer to an Azure function. Again, there are different services available on different platforms. The Google cloud platform could have such capabilities too. But assume that you wrote a small Python program or a Java program or C# program, either one of it, and you need to put it out there to run. Right on your laptop, you can run it. On your desktop, you can run it, but to make it available on the cloud, you need to have something. Generally, before Lambda or before serverless compute, what you would have to do is to go set up a instance, a virtual machine, and then make it available on the internet, and then put the runtime, the Java runtime or the Python installation you have to do, and then you put the code and you run it and you put a web server on top of it, make it available. All that you have to do now, with this capability that is there as a serverless compute, you basically just need to put the code out there and start, and it will be available. So it's as simple as that. You just focus on the code, and they take care of everything other than that. So that is what Lambda is. If that is the same capability that Google Colab does, maybe then it is same. But from the sound of it, it may not. It doesn't look like that.
No, sir, it's just specific for Python. Okay, sir. Thank you so much, sir. Thanks for your awesome answers, sir, and your patient listening also. So the
Thank you,
questioning
Dora
session
ma'am.
is over. Um,
Thank you, sir. Thank you for patient clarifications. Now I call upon Dr. Satya to deliver the vote of thanks.
Thank you, ma'am. Am I audible?
Yes.
Good
Yes,
evening to
ma'am.
all.
Yes.
Good evening to all. I would like to take this opportunity to place on record our hearty thanks to our Vice Chairman, Shri S. Paraniraju sir, for providing this wonderful virtual learning opportunity. I also wish to express my profound gratitude to our principal, Dr. J. Sukumar sir, for his constant support and motivation. I'm also very grateful to Mr. Kumar sir, Head, PG Department of Commerce, Coordinator of IQAC, for his valuable guidance. I must mention our deep sense of gratitude to Mr. Ashin Antony sir for his intellectual presentation. Thank you so much, sir, for your presence and took out valuable time of your tight schedule. Further, we are grateful to the department heads, faculty members, research scholars, corporates, and students for the active participation and valuable queries. Thank you all for your gracious presence. Thank you so much.
Thank you.
Participants kindly fill the feedback form to get your certificates. The link is provided in the chat room. Please make note of that.